Next, we will discuss what one is expected to know after completing a trigonometry course. A student who successfully completed a trigonometry course must be proficient in the following 4 tasks: solving triangles, graphing trigonometric functions, solving trigonometric equations, and working with trigonometric identities. When it comes to solving triangles, we didn't learn everything overnight. There are 3 stages of learning how to solve triangles. First, we learn how to use the Pythagorean theorem and well-known ratios between the sides to solve nice triangles. Next, we learn how to use the definitions of the 6 trigonometric ratios to solve right triangles. And finally, we'll learn how to use the laws of sine and cosine to solve any triangles. When it comes to graphing, we must give trigonometry a lot of credit for its contribution. Why so? Because after completing a full algebra sequence, you only learned 8 functions altogether. Here is the list. But when you take a trigonometry course, you learn 6 trigonometric and 6 of their inverse functions. Altogether, 12 functions, which is a major chunk of all the functions that you must know before entering a calculus sequence. As a result, you are expected to know the graphs and basic properties of trigonometric functions and their inverses. Here is the graph and a list of basic properties of sine function. Here is the graph and a list of basic properties of arcsine function. Here is the graph and a list of basic properties of cosine function. Here is the graph and a list of basic properties of arccosine function. Here is the graph and a list of basic properties of tangent function. Here is the graph and a list of basic properties of arctangent function. Here is the graph and a list of basic properties of secant function. Here is the graph and a list of basic properties of arcsecant function. Here is the graph and a list of basic properties of cosecant function. Here is the graph and a list of basic properties of arccosecant function. Here is the graph and a list of basic properties of cotangent function. And finally, here is the graph and a list of basic properties of arccotangent function. When it comes to solving trigonometric equations, we also didn't learn everything overnight. First, we learn how to solve simple trigonometric equations. Here is the summary of the methods for solving each one. There is also a fancy way of writing all of them, including the first 2 in a single line formula. Similarly to how we have a quadratic formula for solving quadratic equations, you can think of each of these methods as a formula that you may either memorize or have it available when solving basic trigonometric equations. When it comes to solving other trigonometric equations, we usually utilize either a substitution technique or solve it by graphing. Here's an example of solving the same equation using both methods. Here's another equation solved using both methods. Pause and review the solutions if necessary, but make sure you know at least one method. The last skill that you must have after completing a trigonometry course is to be able to work with trigonometric identities. Let's briefly discuss what are they and what is there to do with them. An identity is an equation that is always true. Trigonometric identity is an equation that involves a trigonometric function. Here's an example of a few basic trigonometric identities. Trigonometry is not the only subject that has identities. There are, for example, algebraic identities as well. Here is a few that you should recognize. So what do we do with identities? Identities provide a playground to exercise one's analytical skills. In a standard trigonometry course, you are expected to spend some quality time trying to prove a range of trigonometric identities. But once you're out, you're only expected to remember the basic ones. I will provide you with the following two charts that I developed in my regular trigonometry class. The first chart summarizes all the basic identities, including the ratio, reciprocal, and Pythagorean. It shows how the six trigonometric ratios relate to one another. The significance of this diagram is that it visualizes the fact that from any given trigonometric ratio, we can find the remaining five. The second chart summarizes all other identities that one needs to know after taking a trigonometry course. The identities are grouped according to their type, and each group has a name. We discussed what one is expected to know after completing a trigonometry course and before entering a calculus sequence.